Look at this line of code. Radius is set to radius plus 1. If your math teacher saw this, they'd mark it wrong. Subtract radius from both sides, you get 0 equals 1. Impossible. But every programmer writes lines like this every day, and they work perfectly. The reason reveals something deep about how computers think. In math, the equal sign asserts a truth. X squared equals y means these two expressions describe the same number forever in both directions. It's a statement about reality. In programming, the equal sign is an action, it's a command. It says, take the value on the right and bind it to the name on the left. Programmers read x equals 5 as x gets 5, or x is bound to 5, never as x equals 5. That tiny shift in meaning changes everything about how code behaves. Here's the mechanic. When the computer hits an assignment, it does two things in order. First, it evaluates the entire right-hand side down to a single value. Whatever expression sits there, arithmetic, function calls, other variables, it crunches it into one result. Second, it takes that result and binds it to the name on the left. Right side first, then left. This ordering is the key. The left side is just a destination. It doesn't participate in the calculation. It receives. Picture variables as name tags pointing at stored values. Pi is a tag pointing at 3.14159. Radius is a tag pointing at 2.2. Area is a tag pointing at 15.1976. The names aren't the values, they're labels attached to values. Assignment moves a label, it detaches a name from one value and reattaches it to another. The old value isn't destroyed unless nothing else points to it. This mental model is everything. Now the hook resolves. Radius is set to radius plus 1. Step 1, evaluate the right side. Radius currently points at 2.2, so 2.2 plus 1 is 3.2. Step 2, take that 3.2 and rebind the name radius to it. The old binding to 2.2 is gone. The line isn't claiming radius equals radius plus 1. That would be nonsense. It's saying compute radius plus 1, then make radius point there instead. Perfectly sensible. Notice something in that last picture. Area still pointed at 15.1976, even though radius changed. That's not a bug. That's how it works. Watch this sequence. Meters is set to 100. Feet is set to meters times 3.2808, which evaluates to 328.08. Then meters is set to 200. What's feet now? Still 328.08. It did not update. Python has no idea that feet was calculated from meters. There's no link between them. Feet is just a number now. The formula evaporated the instant the calculation finished. This non-link between variables creates a famous puzzle, swapping two values. Suppose x is set to 1 and y is set to 2. We want to swap them, so x ends up as 2 and y ends up as 1. Naive attempt, y is set to x, then x is set to y. Walk through it carefully. Line 1, evaluate the right side, x is 1, so y is rebound to 1. But the value 2, where did it go? Nothing's holding it. It's lost. Line 2, x is set to y, which is now 1, so x stays at 1. Both variables end up as 1. The 2 has vanished entirely. The fix is a temporary holder. Before overwriting y, stash its value somewhere safe. 3 lines. Temp is set to y, temp catches the 2. Y is set to x, y is rebound to 1, but the 2 is safe inside temp. X is set to temp. X receives the 2 from temp. Final state, x is 2, y is 1. Swap complete. The temp variable exists for one reason. Assignment destroys the old binding, so you must preserve any value you still need before it gets clobbered. This pattern shows up everywhere. Anywhere you mutate state, something has to hold the past for a moment. These small puzzles point at something bigger. Math is declarative knowledge, statements of truth that hold timelessly. X squared equals y is always true in both directions, regardless of when you read it. Programming is imperative knowledge, a recipe of steps. Do this, then do that. The computer follows orders top to bottom. It doesn't reason about what should be true. It executes what you wrote in the order you wrote it, with no memory of why. Humans naturally think in relationships. We say feet depends on meters as if that dependency persists. But the computer thinks in moments. At this instant, bind this value to this name. The next instant is a fresh world. Every advanced programming concept traces back to this one shift. Mutation. Values change over time, so the same name can mean different things at different moments. References. Multiple names can point at the same value, and the change in one viewpoint affects others. State. The entire program is a snapshot of which names point where, evolving step by step. Concurrency bugs, two threads racing to rebind the same name, neither knowing what the other did. All of it grows from a single root. Equals is not equality, it's assignment. If you ever want to watch this in slow motion, search for Python tutor online. It animates exactly which names point at which values after every line. Seeing it once cements the model permanently. So the rules to carry forward. 1. Read equals as gets. 2. The right side is evaluated first, completely into a single value, before anything else happens. 3. Variables don't know about each other. A formula runs once, produces a number, and the link to its input disappears. 4. Assignment destroys what was there. If you still need the old value, save it first. Once these 4 habits become automatic, code stops being mysterious. Lines like radius is set to radius +1 read naturally, because you're no longer hearing a mathematician. You're hearing a sequence of instructions.